Hi, I'm Greg Olick with Med-Acoustics, and what we wanted to talk about today is what's involved in the decision-making process when purchasing an auditory evoked potential unit. And so that's why I started with this slide, because it kind of gives us the questions that we have to ask before we can begin to look at what's out there and what would be the best for our particular facility. And what we will end up doing is focusing on the Interacoustics Eclipse, okay? And I'll give you a demonstration of that, point out some of its features and benefits, and compare it with the other systems. Fair enough? Okay. Well, the first thing that one has to decide are the questions on this slide. Do we want a 1 or 2 channel unit? That's important because there are systems out there that are limited to 1 channel. And if having the second channel is important to us, then that would eliminate those. Does it have to be portable? And essentially all systems today are portable because they are relatively physically small footprint, and will run on a laptop computer. But some are a little more portable than others, so that might be a consideration, though they're all portable. And then what type of stimuli do I need? Almost everybody would say, yes, I definitely need clicks, but do I do frequency-specific work, and do I need tone bursts? And then today, if we are doing frequency-specific threshold determinations, then we definitely want to think about an alternate stimulus, a chirp. Okay, and when I demonstrate the Eclipse unit, I'll talk about the advantages of the chirp stimulus. It's an alternative to a click stimulus and a tone burst stimulus. Are we going to be doing electrocochleography? Are we going to be doing Vimps? Do we want built-in norms for latencies? Is that important to us? Will we be adding another function like audioacoustic emissions? And if that's something that we can add, is it viable from that particular manufacturer? Some OAE systems are more viable than others. What about ASSR? Will we need that? And if we do, is that viable? Is that a viable function on the unit that we're ordering? Do we understand its application? Biomap and stacked ABR were two things that were pretty hot several years ago, but today they have disappeared. Actually, the FDA has taken those off the market. They need more research. All right, so those two are no longer considerations, though they were just a few years ago. Will I be doing non-sedated ABRs? Non-sedated pediatric ABRs? If I am, then there are very, very substantial considerations to make when purchasing the equipment. Certain features that are going to make that a more viable application than if you don't have these features. Okay? And some systems have them, some don't. Will I be doing infant screening? And then how, with this particular piece of equipment? And how will I be able to accommodate that? And then this very important one, last one, noise immunity. And by noise I don't mean acoustic noise, I mean electrical interference. I have had situations where the electrical interference was absolutely terrible. In fact, where the system would not run in certain environments. Absolutely would not run. And over the years of experimenting with every system known to man, I've come to realize that the front-end design, in other words, the design of the preamp, is the all-important thing. And some are way more noise immune than others. So that's an important thing too. All right, let's look now at what's out there. Okay, here to me are the 4 top best-selling brands out there, and they all certainly have their place. Okay, over here is the Biologic Nav Pro, Navigator Pro. It is very much a standard of the industry. Okay, and there's probably more of those in use in clinics throughout the United States than any of the others. So that's certainly a viable option. The Vivosonic Integrity, specifically made for pediatric non-sedated ABRs, that is a very good choice in the proper application, the proper facility. In some places, it's not quite appropriate for what they do. In other places, it could be the most appropriate thing. Then there is the Gracie Stadler Audera, and that's probably the second most commonly found a clinical auditory evoked potential system. That one would find in use in the United States. And then one we're talking about today, the Interacoustics Eclipse, and I'll show you what the benefits of that are. Okay? It's a PC-based unit. It's maybe the size of a notebook computer. We normally sit the notebook computer on top of it, though it doesn't have to be. This unit, that is the actual processor, that can be even hidden somewhere out of sight and not take up any desktop space. I put the PC, usually the laptop, right on top of it, because it is about the size of a laptop when the laptop is closed physically. Okay, and there is a small and lightweight preamp, and then a patient cable, and the inserts or bone or whatever you use for a stimulus plugs in the back of it. Okay. All right. So I'm going to leave this and go to the application of the product. This is the Interacoustics Eclipse. Here's what the main features are. One is very good noise immunity, excellent noise immunity. I could tell you of a case in Gadsden, Alabama, where I tried to install another make and model, and I couldn't get a response whatsoever. In fact, in the EEG of the patient, I saw a modulation of a radio station. You could actually see the audio modulation in the EEG, and I heard the radio station in the earphones. It was a very extreme situation. And once I made sure that I didn't have any problems in the way that the equipment was installed, I asked the audiologist, do you have a radio station nearby? So she opened the curtain of a window, and there was a nice big AM transmitter, just a stone's throw away. And so I said, well, this won't run in here. It absolutely positively won't run in this environment. And she couldn't move. I mean, you know, this was the office, and wherever you went in the office was the same thing. If I tried to get further away from it, it wasn't far enough. So I thought, if anything will run in here, it's the Eclipse. And so I came back with that, and that ran without showing the radio station at all in any of the responses. And so we left that there. What it does is prove that the design of the preamp is such that it has a good deal of noise immunity. This is the preamp. It's lightweight. It can sit around the person's or even around their neck, or even clip onto them. And then there is a short patient cable. And there's an impedance tester, a very easy to use impedance tester that's built onto the front of it. So the design of the preamp gives it a extraordinary amount of noise immunity. So if that's important, if you're going into the OR, or if you have a known hostile electrical environment, which some offices do, just because of equipment and computers and all that are around, then this would be a very good choice. Okay? That's one thing. Another thing is there's a feature in the Eclipse which no other clinical ABR or auditory evoked potential system has. The only one that comes close to this, and in fact has something very, very similar, is the Vivosonic, the unit that's made specifically for non-sedated pediatric ABR applications. This system has what's called Bayesian weighting. Bayesian weighting is a method of filtering the responses from the patient coming in, sample by sample. And the way they do it is to look at each sample and analyze its signal-to-noise ratio. Does it have a very poor signal-to-noise ratio, or does it have a very good signal-to-noise ratio? And this is done very quickly, say 40, 50 times per second, and they're instantly analyzed and given a score or a weight. And those that have a good score, in other words, a high signal-to-noise ratio, then they are given a high weight. So when they are calculated into the average, they contribute more, much more, than the ones that have a poor score, have a low signal-to-noise ratio. Those contribute to the average also, but they contribute less because they're not as good. So nothing is rejected. There's no artifact rejection. Every sample is taken, but its weight, its contribution to the final average is dependent on its signal-to-noise ratio. So this way, when a pediatric patient is not sedated and not just sitting or lying down quietly, perfectly cooperating, right? Not sleeping either, when they are awake and but naturally they're the type of patient that can be relatively calm if you blow bubbles for them or play blocks with them or let them watch, maybe without the sound on, a video. If it's that type of patient, right, reasonable pediatric non-sedated case, then this works great. On a conventional system, these responses with the patient may be up and active, slightly active, would all be rejected because all you can do is set a rejection level. So any myogenic artifacts would be rejected. So Bayesian weighting, right? That's a feature. And then there are others. Let me show you, for example, one thing this has is chirps. Now, the chirp stimulus is unique to products that are in the family of products owned by a company called William Demont. Okay? William Demont owns Grace and Stadler. They own Interacoustics. They own Mako. They also own Medrex and Micromedical, Oticon, and many other companies. Okay? Radio Ear. And they have a patent on this stimulus, and it is called the chirp stimulus. The bottom line is it overcomes the physical problems of the cochlea in delivering an efficient evoked potential stimulus. And the problem is the timing of the cochlea. As you know, it takes longer for the low frequencies to travel the basilar membrane to get to where they're going to stimulate their part of the cochlea. It takes less time for mid-frequencies and much less time for high frequencies. Well, the chirp is timed so that the low frequencies actually arrive and start their journey to their place sooner than the mid-frequencies. And the mid-frequencies arrive and start their journey, timed just right and sooner than the high frequencies, so that they all arrive at the same time and fire at the same time. And what does that mean? That means a stronger response, a response that is 25% to 50%, and sometimes even 70% higher in amplitude than the response you would get from a click. And therefore, you'd have to do less averaging because this will stand outside of the noise and be recognizable sooner, faster. So, bottom line is a much faster test and a cleaner result, and actually being able to get closer to threshold. Okay, I'll show you an example of it here. This is a test where we used the chirp, and here's the right ear, here's the left ear, and notice the click rate, or the stimulus rate. It's not click, right? Stimulus rate at 44 stimuli per second, and these were acquired very, very quickly. In 1/2, sometimes 1/3 the time that it would take with a click. These are also available in narrow band chirps that would replace tone bursts. And again, it's just more efficient. It's faster, better response, cleaner response, down closer to threshold. Okay? So the chirp is another thing that would be an advantage for a practice that's doing especially frequency-specific threshold work. So we have Bayesian weighting and we have the chirp as two big features. Let me show you some of the just operational features. I'm in the edit mode now. I pulled up a patient that I have already done this test on. And now I want to maybe do some things with this. One of the other features of the Eclipse is that every time you run a wave, two waves are actually collected. And what you see is the average of both of them. Okay? So an A and B is collected simultaneously. You almost never have to do a replication run. Audiologists are used to running replications. For every single run, they run on an ABR. And the reason for that is because if it doesn't replicate, you must investigate, right? Famous J. Hall saying, on the day after Johnny Cochran said, if the glove doesn't fit, you must quit. Remember that? Back in the 1990s. Anyway, replication runs are almost never needed here. I'm going to show you why. Here at 60 dB, we ran this chirp response. Looks very much like an ABR response. Well, it is an ABR response, but it looks very much like a click response because the chirp is timed so that the broadband chirp that replaces the click produces a response with about the same latencies as the click would. Okay? But watch this. I've chosen that particular waveform, and I'm going to hit this icon that says AB. So now I have my A and B replications superimposed on it. And so I can see without any more information that this is indeed replicated. And I didn't actually have to run that replication because both A and B were acquired simultaneously as I had acquired this waveform, and they're available. The waveform that I see is the average of both. It's really a smart way of doing it. And so here's my 40 dB response. Let's see if that replicated. Sure did. So I have automatic replication without me doing it. Here's my 20 dB response. Okay, did that replicate? Yes. Pretty nice 20 dB response. Okay, and acquired within just a few hundred stimuli rather than a couple of thousand or more. Okay, and another feature would be if I want to mark these. Okay, I can choose this particular icon up here which says suggest markers, suggest waveform markers. In other words, watch. It's like magic. Boom. Is this where you would have marked 5 if you were deciding that? Sure it is. But it did that for you. Okay? Now, every once in a while, you might disagree with it. And you might say, well, geez, I think it should be somewhere else. Well, you certainly can move it and mark it somewhere else. Override this. But it is a big help. And if you had done this at higher intensities and you had waves 1, 3, and 5, well then it certainly, whether you were using a click, a tone burst, or a chirp, it would mark those for you. Okay, so that alone saves time. So there are some time-saving features in this system as well. And of course, there are norms in it. Here we have the normal area for wave 5 for the age of the patient that we just did, and you can see that the 60 dB, 40 dB, 30 dB, and 20 dB responses that we marked are plotted on this latency intensity graph, and they happen to fall. This is my wife's Jan's ABR, and they happen to fall within the normal range, so she's good. Okay. So there are norms incorporated in here. You don't have to put them in; they're already in there. Where do we get them? Mike Gorger's research at Boys Town. Okay. If you want to mark any particular wave, like I want to mark this wave 3, well, I just make that wave active, and I can go over here to 3. See, and I then click, and I've marked wave 3. So it's very easy, efficient operation. And of course, if I'm on any particular wave and I want to see my latencies, they're right here in this graph. Okay? And my interwave latencies are right here. So that, I hope, is a good explanation of the benefits of Bayesian weighting, the benefits of the chirp stimulus for both broadband and frequency-specific testing, the benefits of some of the other features in here, like running replications automatically, and even marking waves automatically. Those should be a help. Let me show you some other things. I'm leaving the application of the ABR right now, and this is asking me if I want to save changes like the marks that I just made. And I'm going to say no, so I can show that to somebody else again sometime. And I'm going back to the database where I have Jan's case here, and I'll maybe want to show you some other work that we've done. How about some Vimps? I just chose a Vimp that we did on her, vestibular evoked myogenic potential. Oops. There it is. And you see how nice of a response that we have here. Okay? This is the Vimp response on the right. Here's the Vimp response on the left on this patient, Jan. And in fact, Gary Jacobson and the audiology clinic at Vanderbilt has been working with Interacoustics on this system and on its application of Vimps. Now, as you know, the FDA has not allowed any of the manufacturers in the United States to openly implement this function on their system. So unlike systems that are sold in other areas of the country, this button is marked minus 20 dB, meaning when you press this, the amplifier gain goes down by 20 dB. If this was sold in Canada or Europe or anywhere else in the world, that would say Vimp on it. Okay, but we don't say Vimp, we don't say the V word in marketing any of these products. However, nothing stops you as a clinician from doing this auditory evoked potential test. And so the Vimp is another test that can be easily implemented on these with no problem at all. We've been doing Vimps with it quite a bit, and some research on different techniques. And if you want to learn more about Vimps, we have an entire introductory presentation on Vimps on the Med-Acoustics website. Okay, let me see if I can show you something else that we did on Jan. Okay, here's a 2,000 hertz chirp. Let's see if we like that better than a 2,000 hertz tone burst. Well, pretty good. Does it replicate? Well, let's go down to the threshold that we found and go to our AB. Pretty good, huh? Not running a replication run, but right down the threshold, pretty solid there. Okay. My producer is telling me to move over. Okay. Anyway, so we've looked at the Vimp application as well as the ABR application. I don't think I have an ECOG done on this patient, but we've done a lot of ECOGs with the Eclipse product, and we get absolutely perfect, immaculate electrocochleography responses. And we also have another feature, and that is, besides measuring the AP-SP ratio, in other words, the difference in the amplitude between the summing potential and the action potential, besides just measuring that, which it does, and calculating that ratio for you, which is the normal indicator, or the usual indicator of whether an ECOG is normal or not normal, it actually has another feature as well, and that is that it measures the area ratio. Not just the amplitude ratio, but the area ratio. By area ratio, I mean the actual area of the summing potential versus the area of the action potential, and calculates that ratio as well. Well, without going into all the details of how that's done, the bottom line is, when you do that, as well as the AP-SP ratio, the system does it practically automatically. You do have to mark 2 other points, so you're marking 4 points instead of 3 points. But the point is that it increases the sensitivity of this test. The sensitivity of the ECOG test to actually finding cases in lymphatic eye drops, Meniere's, is relatively low. It's 53 to say 62% sensitivity when patients are not having an episode. You know that this condition is episodic. So you almost have to tell the patient, well, call me when you're having an episode, and then run down here in the ambulance so we could test you during the episode. Well, since that's not practical, many ECOG tests are done when the patient is not having an episode. And so you have a poor sensitivity to actually finding this pathology with it. The sensitivity can be raised to 82%, research shows, by measuring the area ratio as well as the amplitude ratio. So that's a feature that's in the Eclipse as well. So as far as I'm concerned, those are the main things that makes the Eclipse one of the most compelling systems on the market today. I am also on their advisory board on the next version of software that will be released sometime next year for the Eclipse, and there will be several changes made to make its operation even easier than it is now. So I hope that's helpful. And we also, if you go to Med-Acoustics.com, you will find a introductory lecture that we did a couple of weeks ago on electrocochleography, and it includes some samples, which you'll see, and also the area under the curve of measurement.